Alright, so today we'll be discussing Schrödinger's cat. So, a little bit about the history of Schrödinger's cat. So, it was created by Erwin Schrödinger in 1935 and kind of touches on the ideas of quantum superposition and quantum mechanics. So, Erwin Schrödinger was born in the late 19th century and was a Nobel Prize winning theoretical physicist. His papers produced the foundations for quantum wave mechanics, and his partial differential equation is the basic equation of quantum mechanics. Notable works of his include My View of the World from 1961 and Nature and the Greeks from 1954. Quantum mechanics is a branch of mechanics that mathematically explains the motion and interaction of subatomic particles, and quantum superposition is where a part of a quantum system exists in several different quantum states at the same time. Schrödinger's cat also touches a little bit on quantum entanglement, and that is a phenomenon where quantum states of multiple objects must be described in reference to each other, even though the objects may be spatially separated. And we'll touch just slightly on that in the next section. So let's talk a little bit about what the actual Schrödinger's cat experiment was. So Schrödinger's cat was a thought experiment that explored the idea of superposition. The experiment goes as follows. First, place a cat into an isolated system with a radioactive chemical, and then wait. Rules of the quantum theory indicate that until the container was opened and the cat's state was measured, the cat could be both dead and alive in a state of superposition. So this does touch a little bit on quantum entanglement, as it's said that you could have two cats in two boxes with radioactive chemicals and then literally put them on different sides of the universe, and their fates would kind of entwine, where instead of there being a chance of both cats being alive or both cats being dead, only one cat can be alive and one cat dead, or vice versa, where one cat is dead and one cat is alive. And that's just kind of how they are described in relation to each other, considering the Schrödinger's cat experiment. So, a little bit on how the thought experiment applies to physics itself. So the idea of superposition that Schrödinger's cat proposed is similar to an electron circling around a nucleus. There's a possibility for that electron to be anywhere around the nucleus that is allowed, and can have any of the allowed states or positions at the same time unless it has been measured and we can confirm its location. So let's talk a little bit about why Schrödinger's cat, the idea of quantum mechanics and quantum superposition, is important. So the idea behind the natural sciences in general is to just kind of explore and explain why the natural phenomena that happened in or around this world happen, and just help us have a better understanding of that. So that's kind of how quantum mechanics works. So, quantum mechanics explains the structure of the atom, which has enabled us to arrive to the level of understanding of physics and chemistry that we have today. And these ideas just kind of help to explain the natural world around us. So, quantum mechanics have practical uses, such as powering clocks, to kind of more complex uses, such as cryptography. So, Schrödinger's cat was a complex paradox that led to the exploration and better understanding of quantum physics today. All right, this has been real. Okay, bye. See you.